Hi, I'm Gabrielle. I'm a course developer at Udacity, and I'm here with...
Hi, I'm Zev. I work at Raise Labs in Boston, where I'm an iOS developer and design groupie.
Zev, so I wanna step back to the beginning of your engineering career. How did you first get started learning computer science?
I wouldn't say that I necessarily learned computer science. I thought I was going to go to school for filmmaking, and I started at the new media program at the University of Maine, and they have a broad selection of intro classes, and one of them is programming, and I sort of took to it. So the filmmaking fell by the wayside, and I got more and more into programming.
And when did you start working with iOS?
Pretty much as soon as the SDK came out. I knew it was coming out. I had been following Apple for a long time, and I knew that object-oriented programming was this big thing that they were pushing, and I was like, well, what is that? I don't know what that is. So I took a class in object-oriented programming in Java at school, sort of to prepare for that, and then just started doing iOS pretty much self-taught from then, using the Stanford course and Stack Overflow a lot.
From the very beginning.
Yeah.
So you're sort of iOS self-taught.
Mm-hmm.
What was your first app?
I did some apps in school, I was in a class where we were studying multi-touch, which was pretty new at the time. This was before the iPad, so iPhone was out, iPad wasn't yet. There were those big touch tables that Microsoft and other people were sort of thinking, maybe this will be the next big thing. Yeah. So we designed a card game, me with a group of students. We designed a digital card game on a big touch table where the idea was, can we get people to use their existing knowledge of how a physical deck of cards works to inform how they interact with cards in the virtual world. So if we think they're likely to interact with cards by picking them up a certain way, can we try to interpret those gestures so that they don't have to think about what they're doing?
Whoa, cool. Did it work?
We learned a lot. What we learned is that the gestures that we predicted that people would use were too restrictive. So we built something, when the iPad came out, shortly after we started this, we scrapped the touch table and went with iPad. And we built a system of gestures where we thought, well, maybe if you're going to move a card, you'll use 2 fingers on the outside, and you can pick up a deck this way, and maybe you'll spin, maybe you'll flip the card. So we built gestures for those, and we brought our prototype to different age groups. We brought it into a middle school, and we asked them, okay, how are you going to flip a card over? And they all double tap the card. Even though we told them this is a real deck of cards, they're so familiar with digital stuff and with iPods that they were all double tapping. We brought it into a senior center. They were in the middle of a bridge tournament, and we said, hey, can you try this out for a second? And we asked them to flip a card over, and they would put their finger on the card, pull it towards them, and lift their finger up off the screen. And you could kind of see in their eyes there was a flash of surprise that the card didn't come with them. And we were sort of resistive to that for a long time. We were thinking, well, there's no way that we can interpret that. But I think we probably could if this were something we were going to pursue and keep working on.
Right.
I think there would be a way to figure out, based on like velocity, you come towards the screen and then come off it.
Right, and sort of differential pressure.
Yeah. Oh yeah, especially with the new pressure stuff, I think you could do it. And I think our main takeaway there was that your users are always going to surprise you, but if you can figure out, if somebody does an action and you know what they're trying to do, don't tell them they're wrong.
Right.
Just make your app respond to them. Make your app do what they're trying to do.
That seems like a really hard problem, addressing the needs of middle schoolers while at the same time addressing the needs of seniors. How have you solved that problem in the past?
So I think this app in particular was on the high end of the spectrum for the broad range of people that we need to work with. But in general, I think testing, do usability testing with people from all the different age groups, with people with disabilities, get as broad a range of test subjects as you can and really listen closely to what they're saying, because they're going to say stuff that is exactly opposite of your core assumptions about the product. And it's really hard to not resist that, to say, no, you're wrong, you're interpreting this wrong. You need to take what they're saying and not judge it immediately, and then go back and think about it and try and figure out, can you make changes to your thing so that it will work better with their assumptions?
Yeah, so give your users a chance to speak and really listen to them.
Yeah.
Within iOS, Do you feel like you have a specialty? Are there certain kinds of problems that you're naturally drawn towards?
Yeah. For me, it's finicky details of UI. It's, when you navigate in a push animation and then you tap the back button, as you navigate back, the cell will unhighlight. But if you navigate back with a swipe gesture, it will unhighlight as a function of the percentage of the drag. So if you drag a bit and then drag back, it will start to re-highlight. And there's a subtle bug on iOS where that doesn't always behave exactly the same in all situations.
Whoa.
And chasing down, so noticing things like that, and then chasing them down and teasing them apart and figuring out like what is actually the intended behavior here, why is it the intended behavior, and how can we best support it so that users aren't distracted by it. Those are usually the types of things that people on my team come to me for. They're like, hey, I have this really weird little fiddly, like what's going on here? This picture doesn't look quite right, but I don't understand why.
Interesting. So somewhere between like a UX specialist and a design engineer.
Yeah. My first job, I was half iOS engineer and half designer, of straddling that world and being the person who would run around between designers and developers and translate each other for them.
So here at AltConf, you gave a talk on Bono.
Yep.
Can you tell us a little bit about how it works?
Sure. So Bono is a library for making attributed strings a pleasure to work with the goal of making beautiful typography on iOS. So attributed string is great. It's really powerful. You can do amazing typographical things. Anybody who's just come out of design school and whose head is full of all these kerning and leading and tracking and the character alternates and all that stuff, attributed string on iOS can do all of that, but it's super finicky to work with. It's a complex and multifaceted API. You need to know, is this in the attributed string or is there paragraph style? Do I need to make a font descriptor? There's a lot of sort of cognitive load that a lot of, especially like project leads, aren't necessarily going to know if they're more generalists. Yeah. And so a designer will come up to you and say, hey, can we just track that out a little bit just to increase the letter spacing? And you don't want to have to say, that's not really going to make the cut for this release because it's hard to do. You want to just be able to say, sure, I can do that. So that's the goal of Bono.
Cool. And so how long has it been out?
It's been out, I checked in Git the other day, it's been out 1 year and 2 months.
Oh, nice. So what are some examples of some apps that use it?
Let's see. We shipped it in the app for Invaluable, which is an online auction app that we did at Raise Labs.
Oh, cool.
The app that caused it to come into existence was Undercover Tourist, which is an app for amusement park enthusiasts. I didn't actually get to use Bono in Undercover Tourist because by the time we'd finished the project and shipped it, that's when I started working on Bono, and we never got a chance to go back and use it. But on an app like that today, I would definitely use it, and I used it pretty much exclusively on my last 2 apps, which haven't shipped yet, on iOS. One of which I can talk about, which is for Perkins School for the Blind. It's an app to help blind people find bus stops, and we're using it in that.
Whoa, yeah, I heard one of your teammates give a talk on that. It's totally an amazing project. Maybe you can summarize the project?
Sure. So GPS is amazing for blind people because it can tell you where you are, which is a sort of core thing you would need to know. But it can only, so if you're trying to get to a bus stop, for example, it can only get you to within sort of 25 or 30 feet. It's not accurate enough to get you right there. So you have this problem where you might think you're at a bus stop, but the bus stop is over there, and then the bus drives by because you're not standing right at the bus stop.
Right.
So the solution that the Perkins app uses is to crowdsource hyperlocal data. So it gets you near the bus stop, and then it'll tell you with the screen reader, with VoiceOver on iOS, if you're approaching the bus stop with the street on your left, there's a bench, and then there's a trash can, then the bus stop is mounted on a concrete pole with a square shape. So if you feel it, you can tell what shape it is. And then if you get to the tree, you've gone too far. Okay. And so that data is gathered mostly by sighted users and then used by blind people who are trying to find a stop.
Interesting. So I wonder if the sighted users noticing the landmarks that are still most useful to the non-sighted users?
Yeah, that's a good question. We did a bunch of testing to sort of figure out some of that, and the app prompts you. It doesn't just have free text entry. It prompts you with lists of things that are likely to be around bus stops based on, it's in Boston right now, and we based it on like going out and looking at bus stops and figuring out what are the types of objects that might be relevant to a blind person that they could feel, they could sense the texture with the cane or by feeling it. and so the lists are pre-populated with that kind of stuff. There's also free text entry if you need it, but it should help guide you to providing useful information, like the poll shapes.
Right.
We found some interesting edge cases, like one of the options for poll shape was a U-shaped poll, so this would be a flat metal sign with the sides bent in, so it has a sort of U-shaped cross-section, but U-shaped doesn't mean anything to somebody who reads Braille.
Right.
So we had to change it to a poll that's open on one side.
Huh. Yeah, I don't think I would notice.
That was another example of users surprising you.
Right.
And also, Chris Hoag talked about in his talk a case where our mental model was completely wrong from how an app user was going to use it, because we were looking at the sign as though we were looking through the sign to the street, so the things were to the left of the sign and to the right of the sign.
Right.
And so the app told somebody there's a driveway to the right of the sign. Mm-hmm. And we have this video of our testing session with him. He said, well, I don't understand that. That's impossible. How could it be to the right of the sign? Because he's picturing walking along the sidewalk with the street to the side of him.
Right.
And so a driveway or some other obstacle is going to be either in front of or behind the sign. And it's hard. That's another case where it's really hard to tease out what people are thinking. People have completely different mental models of the things that we all think are things that we share in common. And you've got to really dig deep to get past the language that we share to like, what are you actually talking about here? And realize that you're talking about something completely different in language that we both think we understand to mean the same thing.
Right. So it was only through user testing that you could figure out that your users are perpendicular.
Yeah,
Their model is perpendicular to to your model.
And we can't tell them we're wrong. We got to change the app.
Yeah.
And we did.
So cool. So do you have so it's not out yet, right?
Right. It's in beta so that we can gather a full set of data for Boston from sighted users. Mm-hmm. And then I believe it's going to go out after that.
Cool. And do you have blind users testing it now as well?
Yeah, so we're working with the Perkins School for the Blind, and they've been working with us closely on testing it and giving feedback. And I also got great feedback from the accessibility labs at WWDC. Brought it there. Like, if you ever have a chance to bring specific questions and problems to the WWDC labs and the by appointment design reviews, it's amazingly valuable.
That leads into sort of, is that one of the reasons why you come to these conferences, to get the chance to talk to Apple engineers? In general, what do you like about these conferences?
So the sessions are great, but they're also now streamed and downloadable. So right now while I'm here, most of the iOS team back in Boston and the one here in Oakland are watching the sessions and taking notes. And it's relaxed and they can pause them. And so I'm not really spending much time in the sessions. I'm just going to the labs. I've got a list of, I think, 19 questions that my teammates have sent me, and they keep posting more. And I'm just running around the labs, tracking down engineers, trying to get specific answers, doing follow-ups, really digging into these questions and figuring out what's going on. It's also a great sort of networking opportunity. I meet a lot of cool people. I see friends who I've met at other conferences.
Nice. Yeah, that's my favorite part, is the networking. And you've had luck getting all your questions answered. The questions from your team.
Well, questions from answers from Apple are often, please file a bug. But it's a good way to get your problem in front of the person who worked on the thing, and maybe phrase your question in a way that is harder to convey in writing and say, like, I don't think you really gave this question or this bug a fair shot. Here's why we think this would be really valuable, and maybe show them some new angle so they might rethink something. We also, at my last job, iOS 6 introduced an issue where our Wi-Fi basically didn't work for a year. And you would get on the network, and then after a few minutes on the network on iOS 6 and macOS 10.7, you would get massive packet loss. It was basically unusable. You had to restart the network on your device. And after, I filed some radars, they were closed or sort of ignored, and I brought it to the labs and was like, this is really a problem for us. Can you please, is there anything you can do? And they reopened it and they gave us some diagnostics to run, and then they said, hey, can you try checking this box in your Cisco router settings, some media packet optimization thing, and we checked the box, and then it worked.
Oh my gosh.
So WWDC Labs saved our company from broken networking.
Wow. Speaking of sending questions to people, we have some questions from our students, so I want to read one to you. Let me grab it really quick. Okay, this question is from Leo. He's in the iOS Nano degree at Udacity. And he says, how do you step out of a rut? I've been working on a bug for the last 3 days. I've done all that I can think of to fix it, but it still won't work. I feel like I need a different approach to tackle this problem. Has something similar ever happened to you?
Yeah, that happens to me all the time, probably every couple weeks, depending on what I'm working on. So change your location, move somewhere else in your office or wherever you're working, go for a walk, step away from the keyboard, give it overnight, sleep on it, go for a walk outside, change your scenery, talk to people. Talking through a problem, like explaining a problem to somebody else, is a fantastic way to debug it, either from getting help from them or just forcing yourself to phrase it in a way that you can convey it to another human by vibrating the air between you. Yeah. It can be a really good way to get yourself to formulate the question in a different way.
Yeah, forcing yourself to explain it step by step.
Yeah, and then of course the higher level of enlightenment for a programmer is to get rid of the other person and get a rubber ducky and explain it to the rubber ducky, and so that you can save your teammates some time. But I think talking through it is certainly something that helps me.
That was the only question we had from our students. And I'm wondering, do you normally code in Swift or Objective-C?
It's Swift for all new projects at Raise Labs, unless we have a really good reason not to. I'm working on this open source library, Bono, which is written in Objective-C because that's what I was using at the time I wrote it. And it makes it easier to support compatibility with Objective-C and Swift projects. And I want to support developers who are locked into Objective-C because of big old code bases. So I'm not ready to port it just yet, but I will sort of a couple of years down the line when Swift is a bit more prevalent.
So most of our students are learning iOS development for the first time in Swift. Mm-hmm. What advice would you give them? What advice would you give the intermediate programmer who's learned iOS development in Swift and now they're not sure how much time to spend learning Objective-C?
Sure. So learning iOS by learning Swift first terrifies me because I learned Objective-C first. And learning iOS development with Arc without learning manual memory management terrifies me because I learned on manual memory management. So the way that I think about problems with memory and everything related to the system is sort of locked into the way that I learned it. But it's kind of cool that people are now learning on Swift first because it does leave a lot of baggage behind, and it really makes you think hard about what you're trying to express to the compiler. It maybe makes it a little bit harder to just sort of throw some code in and get it working, which, again, based on the way that I learned it, is terrifying because that's how I learned Objective-C, is like throw some stuff in, the compiler won't tell me what I'm doing wrong, I've got to sort of run it and try and figure it out. And hopefully as the error reporting gets better, it'll be more clear earlier as you're typing code what you're doing wrong. But also still just throw stuff at the wall and see what sticks. Like hack together the ugliest solution you can and just get the thing working and then work on trying to improve it and make it beautiful.
Yeah, that's not really possible in Swift because you have to be so specific about what type you're using for what purpose.
Yeah, and there's always the danger that something's going wrong and it's not your fault in Swift because the tooling is not as mature as it is with Objective-C, right. But it's getting there, and it's getting there fast.
Do you think that Swift is a good language is a good first programming language, is a good language for people to learn if they've never written a line of code in their lives?
I think so. From what I've heard from people who have started out learning Swift, when I think about that, my mind immediately jumps to all the edge cases and all the weird things where, like, the thing with learning programming is pretty easy to teach. Like, here's a loop, here's a conditional, okay, now you're a programmer. The things that were annoying to me when I was learning programming were, wait, floating point numbers do what now? And all the weirdness, all the garbage that comes from the fact that this is not a pure logical system. We're dealing with computers, we're dealing with silicon, and there's grossness to be had there. And I think Swift probably leaves most of that grossness as far under the covers as is reasonable. Similar to a language like processing, which is based on Java, but gets rid of a lot of the awful system.out.println stuff and makes it really clean and pure to write little programs that do graphical things. I think Swift is very similar. It's really clean to do simple things, and you're not going to run into those gross edge cases that make you question your existence and wonder, like, wait, how do computers work again? How is any of this even working?
Is that a good thing? Or like, when is that a good thing and when is that not a good thing?
Yeah. And there are certainly people who, learned assembly first or learned very low-level things first who are going to be horrified that anybody's learning a high-level language first. It's the kids these days fallacy.
Right.
So you're always gonna be cruising along and find stuff that makes you question all your assumptions. I think where Swift draws those lines is probably in a good place. It mostly does stuff you would expect, and then in the places where you normally have gotchas, things like various types of casting and coercion that could surprise you in other languages, it makes it hard to mess those up because it makes you be pretty explicit about, like, this is a floating point, this is an integer, you need to do some stuff. You need to think about what you're actually trying to say here. It's really hard to, though not impossible, it's hard to do division and expect to get a floating point and actually get an integer, except in some cases. But I think
because you had to be very specific about it in the first place.
Yeah, when I was learning programming, I made all those mistakes. I think many, though not all of those, are obviated by Swift. They're harder to make. I think there will still be cases where you have to go read the thing that's like things about floating point numbers that every programmer should know. If you didn't study that in school, you're going to have to go learn that at some point. But I think for the most part, in most cases, also because the things people are writing in Swift are sort of more things in UIs for now. It's moving towards the server and things, but the details of floating point numbers and things like that are less relevant when you're moving windows around on the screen.
What are some of the most exciting announcements coming out of WWDC for you this year?
For me, it's got to be the tooling, the improvements to Xcode and just the build stuff and the Swift open source progress. Mm-hmm. I got to try out Android Studio recently. I've never done Android programming, and I wrote a feature on an iOS app that was mostly matrix math, so very little language dependent stuff. And I thought, well, this will be fun. This is a cross-platform project. I'm going to try porting it to Android, pull out my Java from college, and the tooling stuff in Android Studio is really impressive. It's fast. The compiler doesn't randomly crash while you're doing stuff. It does the auto importing, and it has just in general a lot more awareness of what you're trying to do, and offers you helpful additions like, it looks like you might be trying to refactor that. Let me help you that. Let me help you do that. Let me provide a lot of support for that. And I think Swift, I'm really hopeful that and optimistic that Swift is going to get there because of the way that the tooling is progressing. It seems like it's giving you more and more awareness into what the code is doing, and using Android Studio gave me a glimpse of what that's like on a mature set of tools. Mm-hmm. And I think some of the changes this year with the visual memory debugger and a bunch of other editor extensions, I think we're much closer now with Xcode.
Cool. Can you summarize for the students just how the visual memory debugger
it's
works?
Really cool. I haven't gotten to play with it much, but when Arc came along, it got us all to think about our object hierarchies and our relations of stuff in memory, not in terms of I'm going to allocate some stuff and do some stuff and then later release it, but in terms of an object graph. So I have an object, it's holding a strong reference to this other object, and the life cycle of this is now tied to this. And you can do that on paper, you can do that on a whiteboard, but now you can actually see it in your code. So
cool.
Yeah, you pause your application, you click a button, it shows you, it takes some object and then sort of traces back, looking at all the strong and weak references to it, and figures out this model of, okay, what's everything that's holding a reference to this? It's what I've always wanted, because in debugging things, I'm often building that model in my head. I go, okay, here's this, and I look through the code, all right, this holds a strong reference, and I draw it on a piece of paper, and now Xcode can do that for you.
So cool.
It's really cool.
Yeah, there's a bunch of places in our courses where we have our students draw object graphs, so now they can just boop, here they are, or compare the ones they draw with the ones in Xcode.
Yeah, and it's a nice companion to the visual view debugger as well. I think those two are really nice. Here is now a view from the top down and from the bottom up of what's going on inside your app.
Yeah, so do you think it makes it easier for beginners and intermediate programmers to learn if they don't have to see those ugly edges in the beginning?
Yeah.
Or do you think it sort of makes them soft?
I think that each one of those ugly edges is an opportunity for somebody to lose interest, somebody to get disheartened. And I think sort of suppressing those and making it so that you can really learn the concepts and really gain confidence that you can make this machine do cool stuff before you then have to start getting into the nitty-gritty. And yes, it's a very valuable tool set to be able to understand the way that this appears in the code is not necessarily exactly what's going on under the hood, but you don't have to understand all of that stuff all the way down to the metal to be a good developer. Like, how far down that stack you go will depend on the kind of stuff that you work on and the kind of stuff that you enjoy, but there's very little of that you have to deal with in JavaScript, and you can build web applications in JavaScript without having to worry about a lot of that stuff because the abstractions are there.
What advice would you give our students, sort of a programmer who's just starting out and they have so many different tools to learn? How do they know where to start? How do they know what to focus on?
Pick a project first. Use the tools that will help you solve your problem and make your thing. Pick a game. It's fun to, if you don't have some other idea in mind, pick a classic game, Breakout or Snake or something like that, just to get started. Pick some problem in your life, something that would be useful to automate, something that you kind of do every day, a scheduler planner kind of thing if you're into that, or if you're more visual, some sort of digital art thing, draw a smiley face, and then Google around, like pick some tool, whether it's iOS or processing or Scratch or whatever, and then just Google, like, how do I do X in this thing? And if your question is too broad, then narrow it down. How do I draw a circle in this thing? And just kind of go from there. Use the tool in service of solving some problem, even if it's a contrived problem that you set yourself.
What would you say to a student who's having a hard time choosing between coding and their other passions?
I don't think it necessarily has to be a one or the other choice. Like, I'm into juggling, and I try to incorporate juggling stuff into programming. I wrote an app that's you can spin an iPad on your finger and it will draw pictures, which is totally a juggling nerd thing.
So cool.
And I'm also into like graphics and UI stuff, and I of course bring that to programming. So I think there's tons of opportunities to take whatever your weird, goofy passion is and like do a deep dive on it and figure out all the nerdy stuff and the notation of whatever the weird thing is that you're into, and bring that to programming and use programming as a way of thinking and a way of problem solving to contribute something there.
Those are all the questions I have. Thank you so much, Zev. Enjoy the rest of the conference.
Thanks.